This video is about another topic I've found that took me a while to troubleshoot the first couple of times I ran across it. I had an I/O problem. There was too much I/O, the disk response time was slow, queries were running slow, and I was just having a bit of a problem tracking down the source of the problem. The query that I'm going to show you in this video will very often give you a surprising result. That's because I/O is the narrowest bottleneck in SQL Server. Sometimes we say it's the biggest bottleneck. No matter what we say, when we say bottleneck, I/O is it. It's the weakest link in the chain of events that comprise a query execution, because the disk is the only mechanical part of the server, unless you're using solid-state disks. Usually we minimize I/O by normalization, database design, query design, most of all by indexes. If you can't find the source of an I/O problem, think of this video and remember that you would like to compare how much I/O is being generated by each database and compare the I/O of tempdb to other databases. There are two functions that do this. One is sys.f in virtual file stats. If you give it null parameters, it will show you the file stats for all databases on a server, regardless of the context from which you execute the query. We have the newer dynamic management view, DMIO virtual file stats, that takes the same parameters. I haven't read that the function virtual file stats is deprecated, but I'm still going to use the dynamic management view. Now, if we go to the master database, we'll see that there are table-valued functions. Many of them are dynamic management functions. Dynamic management views that are really views are contained within each database. The functions that we still manage to call dynamic management view sometimes are only contained in the master database, but they are still accessible from every database. Regardless of what database we're using, we can access these. And in this one, depending on what parameters we give it, we can limit it to giving us information about specific databases, or for our purposes, the most useful thing will be to compare the I/O between all of the databases, including especially tempdb. Now here's the function, the legacy function. It takes database ID if we wish. It takes the file ID. There is no default. We can give it both nulls. File ID 1 will be the first data file, the MDF file. File ID 2 will be the first log file, LDF. And as we add other NDF and log files, they will be assigned numbers sequentially. Many times all we have is a file ID 1 and 2. Here we see that the dynamic management view takes the same parameters. If you look, you'll see that they give back the same data with different column names. If we look at the query, it is meaningful to go ahead and use a function for a database ID so that we can see what the actual name is. The columns we're going to be interested in are database name, number of reads, bytes read, writes, bytes written. Number of reads is perhaps more important because no matter how much it reads, it's going to take about the same amount of time. It's going to read either 8K or 64K of data, and SQL Server is going to decide. When SQL Server starts up, very often all of its reads are going to be 64K just to try to fill up the buffer to potentially make future queries faster. As the buffer gets fuller, it is going to be more likely to read 8K pages, and you could divide the number of reads into the number of bytes read to see what the average is. We also might think of it, though, as the number of bytes read and the number of bytes written. Generally, we can look at either one. In this particular case, we're going to see there is a bit of a difference because there hasn't been much activity on this server. This is the query that we really want to study. I've declared two variables, the total reads and writes for the entire server and the total bytes read and written for the instance of SQL Server. So the total reads and writes are going to be the sum of the reads and writes for all of them. No filter, not filtering by any particular database. Total bytes will be the sum of the bytes read and written. Then we're going to go to our query, and we're going to group by each database and sum the reads and writes. We're going to look at the sum of the reads and writes and divide it by the total reads and writes. and look at the sum of the bytes read and written and divided by the total bytes. Multiply both of those by 100 to get a percentage. And we're going to look and see what percentage of the I/O is attributable to each database. Now, this particular slide isn't going to show it, but if you do it and you sort descending by either total reads and writes or total I/O, and tempdb is at the top, you probably have a problem. I have seen cases where 80% of a server's I/O is attributable to tempdb. Now, what does this mean? They've got a bunch of complex queries and they're using temporary tables all over the place, which requires the creation of a table in tempdb, and it also has the disadvantage of removing from SQL Server the ability to optimize queries properly. We'll talk about that in a minute. So what can we do to reduce the I/O? Well, the quick judgment might be to use table variables instead. If you view my video, The Cost of Using Temp Tables and Table Variables, you'll see that may not be a good idea. In order to properly use temp tables and table variables for complex queries, it may require that you know a lot more about the statistical distribution of data than you wish, and you may wish to try to eliminate them entirely if you can. And I suggest that your first avenue might be to leverage common table expressions, which serve a similar purpose of taking complex queries and making them simpler. This is something that is one of those things that just jumps up at you and comes out of nowhere, and I suggest you remember it in the back of your mind. We might think we know where all the I/O is coming from, but this query has often turned out to give me insight into difficult situations.